So in this lesson, we need to figure out the sigma notation. And this is what that means, is sigma. And sigma represents a summation for math. So summation means it's the same as a sequence where you're plugging in all the terms, but the difference between a sequence is a sequence you just state the terms. A summation, you add all the terms together. So this is saying add all the terms from plugging in 4 all the way to 9. So you plug in 4 plus you plug in 5 plus you plug in 6 plus you plug in 7 plus you plug in 8 plus you plug in 9. And so you need to find each of those values. So 20 plus 3 is 23. 28 plus 33. 38 plus 43 plus 48. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And so now we just enter those into our calculator. And so entering those into our calculator, 23 plus 28 plus 33 plus 38 plus 43 plus 48. So that's 213. And so this equals 213. So for number 2, for 1 over k, so that's going to be 1 over 3 plus 1 over 4 plus 1 over 5 plus 1 over 6 plus 1 over 7 plus 1 over 8. And you need to add those all together. It's just easier to use a calculator in this sense. For this next one, this is 2 to the j, so this is 2 to the 0 plus 2 to the 1 plus 2 to the second power plus 2 to the third power plus 2 to the fourth power plus 2 to the fifth power. And so that's 1, that's 2, that's 4, that's 8, that's 16, that's 32. And you add those all up together and you find your value. Now on number 4, I know that there's a variable in it. Don't let that deceive you. It just means that your answer also has a variable in it. So you're plugging in the values for k. So this is 3 times 0 minus 5 times x to the k power plus 3 times k minus 5 x to the k power, and then plus, right, because we're adding the next term, 3 times k minus 5 x to the k power. So simplifying each one of these, you get 3 times 0, which is 0, so you get negative 5 times x to the 0 power, that's 1, so you get negative 5, plus 3 minus 5 is negative 2, that's negative 2 times x, and this is 6 minus 5, which is 1 times x squared. So I can look at that like that. And it's kind of interesting because we basically created a function of sorts, or a variable based, summation of sorts, from this summation, which is okay. The last is this exclamation point. This means factorial. And all it means is you just multiply all the factors or all the numbers counting down from that starting number. So 10 factorial equals, you start with 10, and then you multiply all the numbers counting all the way down. So in this instance, if I plugged in 1, I get 1 plus 1 factorial over 1 factorial plus 2 plus 1 factorial over 2 factorial plus, now we're plugging in 3, so 3 plus 1 factorial over 3 factorial plus 4 plus 1 factorial over 4 factorial plus, and then 5 plus 1 factorial over 5 factorial. Now you should see a pattern here that's going to kind of help you in simplifying this. So for example, the top is 2 factorial over 1 factorial. Now be careful, they don't reduce. You have to actually do the factorial first and then reduce. So 2 times 1 over 1, that cancels out and you get 2. So for this one, you're going to get, so 3 factorial over 2 factorial, which is 3 times 2 times 1 over 2 times 1. And so you get plus 3. So you got to be careful, right? You can't, that just doesn't reduce like that. You have to actually write out the factorials. So plus, you get 4 factorial over 3 factorial, which is 4 times 3 times 2 times 1 over 3 times 2 times 1. Those will cancel out, so you're going to get plus 4. And I'm sure you see the pattern now. You're going to get plus 5 and then plus 6, and then you just need to simplify that. So rewriting this as a summation, we need to know what kind of sequence it is. So I could say that this is my a sub 1, or my first term. And so it looks like it's going up by 3 every single time, so I know it's arithmetic. So a sub n equals my first term plus n minus 1 times my common difference 3. So now if I want to start it at 1, right? So if I plugged in 1 here, I'm going to get 8. So what I should do is I should simplify this just a little bit. Well, actually you don't have to. You could say, okay, now summation from, n equals 1 all the way to 1, 2, 3, 4, 5. So to 5 of 8 plus n minus 1 times 3. Like, technically that works. You can do that. Sometimes people like to distribute the 3 and, it doesn't matter which way. Now for graphing these, so remember this is an absolute value and it has a horizontal shift of 4. So 1, 2, 3, 4. And it's equal to, so it's going to be a solid line. So in drawing this, now I need to test, where it's going to be shaded. And so if I plugged in 0, 0, I get 0 is less than or equal to 0 plus 4. That's true. So this side of the graph gets shaded. Now for your next one, you have a horizontal shift of -1 and a vertical shift of -3, and because of that, it's going to be facing down. That's a reflection. So it's going to move over 1, it's going to move down 3, and then so there's my parabola. And now same idea, I need to test and shade. So if I picked 0, 0 again, you get 0 is greater than -0 plus 1 squared minus 3. 0 is greater than or equal to -1 squared minus 3. 0 is greater than or equal to, because that needs to be squared first in this instance. So that's going to be -4. That's true. So that means this side of the parabola is shaded. And so where they overlap is going to be here, just to make it a little more real looking. I kind of like this stencil. It's very interesting.